apostrophe things means? Third derivative. So how do you get to a third derivative? Do a derivative 3 times. That's if you start with, like, to get to y triple prime, you have to do a derivative 3 times if you start with y, right? But what if I asked for y triple prime, but I gave you y double prime? Just do it once, right? So it derivatized. I like that. So it kind of depends on what you're given as far as determining what you do, right? So I gave you y on this one, and I asked for y triple prime. So Maddie's idea of you got to do it 3 times is right on the money. But before you did any derivatives at all, what would you maybe do first? Move the x up. Agreed. So I'd write this as y equals 2 minus 2x to the negative 1. And I'm going to let you guys see if you can run from there. Okay? Once you have it rewritten like that, it's a matter of doing exactly what Maddie said. Do a derivative, then another one, then another one. I'll let you guys try that for a little bit here, and then we'll check your answer. This y prime would be our first derivative. What's the derivative of that first term that's a 2? Right, that's a constant term, so the derivative of that is 0. But then we've got to use the power rule. So it would be positive 2x to the negative 2 as you execute that power rule. That make sense? All right, so then y double prime. Eden, what'd you get for y double prime?
Negative 4x to negative 3.
All right. Young, how about y triple prime as we finish it up?
12x to negative 4.
I like it. It's right on the money, I think. Good job. You guys have any questions? You guys have the gigglies?
Sorry.
It's okay. No, it's okay. All right. So then finding the equation of the tangent line, we've done this before, and you're going to find me repeating this over and over. And hopefully you get the idea that if something is repeated over and over, it's really important to the person that's repeating it. And so we're going to do this again. So we've done this before. We haven't done this exact one before, but we've done this concept before. So what are the 2 things we've got to have to find the equation of a tangent line? Point of what? Tangency. That's right. Point of tangency. And that would be where the curve and the line, the tangent line, actually intersect. Just in that one little point, right? And we also have to have the slope of the tangent line, a.k.a. And I'm going to be really specific, and I agree with you, Nick, that it is a derivative. I'm going to be very specific and say dy dx, or you could say like f prime of x or y prime of x, something along those lines. Okay. And I want to remind you this again. This will be the 3rd time that I've said this, and again, I think it's really important. I've drawn graphs the last 2 times. I don't think I'll draw a graph this time unless you really want me to. At this point of tangency, there are 2 things that are true regarding the tangent line and the curve. At the point of tangency. You guys remember what maybe one of those things is? Same point. That's right. So the xy for the curve and the xy for the line, same thing. What else is true? That's right. Slope of curve equal to slope of line. Yes? Good? So that principle is really important. It'll be important for this one right here. This is calculator active, so we'll use that to our advantage when the time comes. So this one says, find the equation of the tangent line to the graph of f of x equals x to the 4th plus 2x squared at the point where f prime equals 1. So sometimes it's really helpful to, just look at something and figure out, what does this question ask me to do? What's the key word when we're trying to determine what does this question want me to do? Find. Yep. So find helps a lot. So find the equation of the tangent line. So in the end, guys, it's going to be some kind of a line, right? It's going to be point slope or slope intercept. It's just going to be the equation of a line. So let's remind ourselves the 2 things we got to have to do this. We got to have the point of tangency, and we got to have the slope of the tangent line. Do we have either of those right now? Don't we have the slope of the tangent line? What is it? Sorry? 1. So at the point where f prime of x equals 1. Remember, f prime, I wrote it up here. F prime, that is the slope of the tangent line. So this is a little bit different. I know you had a homework question on this a couple days ago, several homeworks ago, where they gave you the slope of the tangent line. What are you not given? The point of tangency. Normally you get the point of tangency and you got to figure out what the slope of the tangent line is. This is the other way around. So I know for sure, in fact, if I wanted to, I could come over here and I could say y minus a y coordinate equals slope times x minus an x coordinate. Isn't that the start of my tangent line? And if I could just figure out what this is and this is, I could just plug them in there into my point and slope and I'd be done, right? Does that make sense? Remember the goal. The goal is to find the equation of the tangent line. And tangent lines, or any other line for that matter, can always be written in point slope form or slope intercept form or whatever you want. And so all I'm saying is, I know what my slope is, so I could put it right there where the slope goes. But I got to figure out the point. Any ideas on how I could find the point of tangency?
The derivative of f of x equal to 1.
I like it. Yeah, so it kind of says it right there, but you got to interpret it the right way. So what is the derivative of f of x?
4x cubed plus 4.
Okay, so that is f prime of x. And I want to set that equal to 1 because it says at the point where f prime of x equals 1. So I've got this slope of the tangent line, 4x cubed plus 4x. I'm setting it equal to 1. It gives me a nice equation. If I solve that equation, I'm going to get some number, but it's going to equal which variable? And wouldn't that be half of my point of tangency? I'd be halfway there. So this is where the calculator probably comes into play, right? So use your calculator to solve that equation, either by using the intersection feature, or you could move the 1 over and use the 0 finder. Same thing, whatever you choose. So you could do this. 4x cubed plus 4x minus 1 equals 0. And then just use your 0 finder to solve it.
It's supposed to be a weird decimal.
It'll be some decimal, yeah.
Can we use polysimal? Does that work?
Say again?
Like polysimal, can we use that just for the equation?
Polysimal.
Do you know, like, here.
Is that some,
It's just like on there, like you don't have to
Oh.
do it. And then you just put the degree.
yeah, fine by me.
And then
If that works out, great. Yeah, that's fine by me. Yeah. Absolutely okay. It's under apps, huh?
yeah,
That's
and it's
weird.
weird. It was nice because it works with like the imaginaries. Like you can set it to give you real numbers or imaginary numbers, so then it can like
And that finds zeros.
yeah.
Okay. Interesting. I'll check that out. Anybody have a solution for this equation yet? Got it? I'm going to write it down. I honestly don't know. Thank you. You guys agree with that number? The one I wrote up there, 0.2367329?
Where do we drop?
What I would do, if I were you, is I would subtract the 1 over like I did,
Okay.
and then
And then just find where it
you
equals.
graph it and then find the 0.
That makes sense.
Yep. And yeah, you can see it's just like
Yeah.
right there near the origin.
Okay.
You guys okay with this? I don't want to assume anything incorrectly. So you found the intersection point there?
Mine is 942.
4x cubed
492.
plus 4x minus 1. Oh, but you have, what's the blue graph?
That is this. And then I did the point of intersection between.
Oh, so we're not looking for where f prime intersects f.
Okay.
What we're looking for, if you look at this equation right here,
It's where it intersects 1.
yeah,
Okay.
where f prime intersects 1.
Okay.
Yep, that's exactly right. Yeah. So Anna, this would be really important, like with that program you're talking about, are you accurate at least to here?
2, 3, 6, 7, 2, 9, 0.
Okay, so we're accurate out beyond. Okay, perfect. That works for me. Yeah, I'm fine with that. Okay. So then, where would that number go within my start of my answer over there? Isn't that an x-coordinate?
X1.
That's the x-coordinate for my point of tangency, so I think it would go right there. How do we find the y that goes with that x? Because the only thing we got to figure out now is the y1. I've got the x, right? I've got the x1. If I have an x and I want a y, I plug it back in. Now let's talk about this. Do I take this right here? Do I plug it back into f of x or f prime of x? F of x, right? Because your output will be y's, right? If you plug that back into f prime, your outputs would be f primes, and you better get 1, right? I would think you would. Okay, so let's figure out what y1 is, and we'll wrap this up. And once you've got it, please just let me know. We'll put it up there and make sure we all agree.
I got 0.115. How many do you want me to do?
3.
Okay.
Yep. Do you guys agree with Anna's number up there, that 0.115? So y minus that equals 1 times x minus the 0.237.
And again, that means you don't care if we do it in like y equals n equals b format because it's just an extra step.
That's fine by me. Yep, I'll definitely check those out. Yes, ma'am. Yeah, that's a really great question. That's why I asked it earlier, because it's really easy to mix up. And really, it's a very strong fundamental question. You got to know it. So what it comes down to is this. It almost comes down to, like, you remember when we did this like last week, where we took a graph of f and then we drew the graph of f prime. We did those over a couple different days. We sketched those. Okay. So what's really important is that we understand, if I've got f of x and I've got f prime of x, what the meaning of the input and the output are. So the input for this will just be x, and the output is a y value. Like literally, if you think about the graph with the x-axis and the y-axis, literally the output is like, all right, this is how high you go, this is how low you go. If I were to look at this other one, f prime of x, the input is still x, but the output is not a y value. The output is the slope of the graph of y. That makes sense? Because f prime means the derivative, and the derivative would be the slope. So if you were looking for the slope of f, you'd plug x, whatever it is, you'd plug it into f prime, right?
Okay.
But if you're looking for a y value, you're going to plug it back into f. So just the understanding of like what the output actually means on the graph. Great question. Anybody else? Questions, thoughts, concerns? We'll bring this up again for sure in the future, but I hope you're listening right now. On your first quiz coming up, I guess it's not your first quiz, on your second quiz coming up, the first one where this really matters, I will try to make a big point about this on your quiz, but I'm going to tell you this right now. If you ever have answers with decimal numbers like that right there, you need to be accurate to the third decimal. Third. That is not random. It just matches what the AP test expects of you in May. And sadly, it is possible to lose points for not including all 3 decimals. You can think of that as a mean rule. It would be really mean if I never told you about it and then enforced it, but the fact that I'm telling you about it means that it's very fair. I'm telling you the rules before you play the game. You got to be accurate to 3 decimals, not 2, not 1, but 3 or more. Like if you're accurate to like 7 decimals, that's fine too, but at least 3.
Do you also round them on the curve?
You know what? Rounded or truncated is okay with the AP readers, and I'm okay with it too.
Okay.
So I'm not going to penalize you for
So you wouldn't care if it was like 0.236 or 0.237?
correct.
Okay.
Correct. Any questions? All right, let's wrap this up then. Okay, number 11. Gives us a g of x. Says find the equation of the tangent line when x equals 2. Then use the tangent line at x equals 2 to approximate g of 2.5. Let's just focus on that first direction first. It says find the equation of the tangent line. We just did something like this. I encourage you, just remember the basic principles that at the point of tangency, the point on the curve and the point on the line are the same, and the slope of the curve and the slope of the line are the same. A little bit of a different question on this one. See what you can do with it. Feel free to compare and talk to each other. Tangent line, you got to have the two ideas there. You got to have the point of tangency, and you got to have the slope of the tangent line. I don't know what order you guys did this, but I'm going to find my point of tangency first. So point of tangency would be g of 2 equals, and let's see here, 24 minus 8 is 16 plus 2, 18. Did you guys get 17? Yeah. Okay. So that means my point of tangency is 2 comma 17. That make sense? Okay. So then the next thing we've got to find is the slope of the tangent line. And remember, the slope of the tangent line would just be g prime of x, dy dx, however you want to look at it. So Heather, what'd you get for g prime?
Like what it ended up.
G prime of x.
So 9x squared minus 4x plus 1.
You guys all okay with Heather's derivative there? I think she's got it. So, of course, that is a correct derivative. It's the slope of the tangent line at any x value, and we don't really want the slope at any x value. We want the slope at x equals 2. So I'm going to write this as, you know what, Eden, I totally understood, even though I stumble on my words sometimes too, so we were on the same wavelength. I got you. So g prime of 2, 36 minus 8 is 28 plus 1 is 29. I think I saw that walking around. Slope of 29. Stu, you good? Everybody good? Okay. So then, if you wanted to, you could write y minus 17 equals 29 parentheses x minus 2. That would be the point slope version of the tangent line. But in honor of Anna, let's go ahead and take it all the way to slope intercept. And maybe others that like slope intercept, she just is kind of vocal about it. So let's see here. Y equals 29x, it'd be minus 58 plus 17 would be minus 41. Did I do that right? Minus 58 plus 17, negative 41. Anna, we agree?
Yes.
Yes. Okay. So I would take either one of these for your equation of the tangent line. How you guys doing?
So we could submit it as the top version.
Totally.
Okay.
If you ever ask me to do one of these, I'm giving you the top version. And if you want slope intercept, you go ahead and do it.
I'm okay.
And be happy. Okay, so are we all settled on that? Awesome. Okay, so now let's take a look here at this other part. It says, once you've done that, then use that tangent line at x equals 2. So we just found that, right? Sitting right there in the box that I just drew. To approximate g of 2.5. Can I give you a brief illustration of what this is? Feel free to scratch this down if you want. It's going to take up a little bit of space. But we are building towards something. Here is my y-axis and my x-axis. And it's a cubic. It's an increasing cubic. So I'm going to say, let's see here. I guess it is 2 comma 17. So I'm just going to say that it does something like that. I don't know that that's perfectly accurate, but that's the general sense of it. And actually, you know what? Let me make it a little bit curvier. I like that better. Okay. So here is my point of tangency, let's say. Here is, I'm going to go with 1 and maybe 2, something like that. So if I sketched in my tangent line, my point of tangency would be here. I guess my scaling, my vertical and horizontal scaling is way off because that's 2 comma 17, but whatever. Here is my tangent line, like so. Graphically, does this make sense? Okay. So then what this says is, once you found that equation of that nice tangent line right there, then use that tangent line to approximate g of 2.5. 3 different people asked a really good question. They said, why on earth would I do this when I already have g right here? Couldn't I just take 2.5, plug it in for x, do a little arithmetic, and be done with it? Right? Isn't that a reasonable question? So it's very reasonable, except it's not doing what you've been asked to do. Right? You've been asked to use the tangent line to approximate. So approximating is a skill that's a little bit unfamiliar with us, and I get it. We're not used to that. We are building towards something, because sometimes understanding what the function is, like the g of x in this case, can be really, really difficult or impossible. The best thing we can do is estimate it, and so that's what we're building towards here. So I totally get, like, why would you do it? Well, here's what I want to illustrate for you. 2.5, let's say 2.5 is like right about here. Do you guys see, it's really tight. Do you guys see how the value of the curve at 2.5 and the value for the line at 2.5 are a little bit different, right? Because we're off the point of tangency. But do you see how they're close, depending on what your definition of close is? In fact, the further I move off that point of tangency, like if I moved over here, let's say it was like 3.5, do you see how the line and the curve would be even further away? So if we're like sort of close, depending on your definition of close, to the point of tangency, then the line is actually a pretty good approximator for the curve. For example, here is a case where this sort of strategy is used. This is a little bit of a sidelight, so we'll finish this here in a second. You guys all familiar with this graph right here? It's a little lopsided, but do you know what graph that is? Sine. Did you know that very close to the origin, this tangent line, very close to the origin, this tangent line right here is a really good approximator for sine? Do you know what line that is? Y equals x. So if you're really close to the origin for sine, of course y equals x, the input and the output are the same, right? So if I said, hey, what's sine of 0.1? 0.1 would be a darn good guess. Do sine of 0.1 on your calculator. In radians, not degrees.
0.097.
Really close to 0.1, right? And so this is a trick that some people will use to be able to approximate. Why would someone approximate? Because it's potentially way faster than finding the exact answer. And as long as you can control the error and be happy with it, then it's good, right? Anyways, so here's what we do with this. It's actually pretty simplistic, what we're doing today. I'm going to say that y, I'm going to use Anna's line here, y equals 29 times 2.5 minus 41. 2.5 times 29 would be, 58, 72.5, I think? 72.5 minus 41 would be 31.5. So I'd say y equals 31.5. So that's the point on the line, right? So when x is 2.5, the line's y value is 31.5. I would say that is approximately equal to g of 2.5. It's approximately equal to the curve's value. It's not equal to it, right? We know it's off, but it's really close. Is it close enough for us? Well, I don't know. Depends on our definition of close enough. It really does. It's not close enough for Anna. That's okay. We can discuss. Yes, go ahead.
Can you also do it like, because the derivative is 29 at 2, and it's like, it means like it goes up 29 over 1. And when it's like 2.5, it's like half. So it's like 14.5. So you do 17 plus 14.5.
Yeah. Oh, yeah, totally. In fact, yeah, if you were going to use the point slope version,
Right, yeah.
definitely do that way. Yep, totally agree. Which might be a thing to convince someone to use point slope. Maybe. We'll see. All right. Let's finish up this 2.3 unit with motion. Yes. All right. So this first question, actually both of these questions we've talked about before, so this will be a good reminder, hopefully. What is the derivative of a position function?
Velocity.
It is velocity function, yep. And then based on what we did with our 15-minute ride, what is the derivative of a velocity function? Acceleration, yes. Okay, so we have a little example here with two different aspects to it. So it says a car is traveling at a rate of 66 feet per second. The brakes are applied. Selected values for the velocity are given below. And notice that the velocity is decreasing towards 0. The car is braking. Hopefully that makes sense. V is measured in feet per second. T is measured in seconds. So remember, the table is giving you time and velocity. So a velocity versus time table, or velocity versus time graph, maybe. The Then it says approximate. So again, I've underlined that because that's a word we're unfamiliar with for the most part, at least doing it in math. Approximate a of 2, a standing for acceleration. Include correct units. So I'm wondering if anybody has an idea about what we could do to take this table, which has to do with velocity, and figure out an acceleration at 2, or at least an approximation for it. Any ideas? Change in velocity over change in time. And you said average something, Anna?
Yeah,
Average what?
like, I feel like, okay, this is kind of what he would say, but if between 1 and 3,
Okay.
you could find.
So you're both right.
Yeah.
You're both right. Speaking up there, that's perfect. So Anna says use the interval from 1 to 3. Why on earth would anyone choose that interval? 2's right in the middle. And it should always be that way. I'm not going to ask you to find I'm not going to ask you to find like a of 2.4 if 2.4 is not right in the middle of something. And I'll probably just leave it with integer values anyways. But 2 is right in the middle. And Andy's idea of change in velocity over change in time, which is really an average acceleration, that's going to be our best estimation. So maybe we say a of 2 is approximately equal to delta v over delta t, which would equal, from our table, what would our v2 be? I think 26, because we're going to use this interval right there. That make sense? So 26 minus 50. Are you guys okay with this? Okay. Divided by what time difference? 3 minus 1. So Nick, are you okay? You said 38 earlier?
Well, I was gonna do the average, no, I did the average of the 1 and 3, of the average velocity.
Oh, you did 50 plus 26?
I thought, yeah.
So that would actually work well if we knew for sure. If we knew for sure that velocity was linear,
Yeah,
that would actually work well,
okay.
but we don't.
Yeah, okay.
We don't.
Cool.
Yep, unfortunately. Does this make sense to you guys? Okay.
Why did you choose the 26 first?
So you could actually go the other way because 50 minus 26 over 1 minus 3 is the same thing. You just have to be consistent. So like obviously the 26 goes with the 3 and the 50 with the 1. So as long as you're consistent, we'll get the same thing and it's totally fine.
Okay.
It's pretty standard practice, I guess, to say like final velocity minus starting velocity. And since 26 was more of like the final velocity for our interval, we would pick that. But either way works, for sure. What do we get? Negative 12? Okay, so negative 12 feet per second squared. Yep. So your acceleration should always have linear something or others, like feet or meters or whatever, divided by time squared. Okay, so this is an approximation of the acceleration at 2. Do you have any questions there? If I'm not mistaken, the final one for this particular section is right here. And it says, somebody did some kind of a regression model, who knows, and they figured out, they think V of t is represented by that equation. And it says, use your calculator to find a of 8. So this is where I'm going to let you in on a little secret. So don't just rush off and do the calculator. Hold off. If the calculator is active, I'm going to show you a little trick with the calculator. Now, if the calculator is not active, which as you know is very frequent, this is going to do you no good. When the calculator is active, this will do you a lot of good. Yes? So check this out. I'm going to, what am I going to do? I'm going to kind of split screens here maybe. Let me just see how this goes. Why don't I move this over? So the quiz is about half and half, I think. So what I'm about to show you could very well be applied on Thursday. And throughout the rest of the year. This will be a help to you, I think. Actually, I know it will. Okay, this is what I want to do. Quit out of that. Whoa. Random integers. All right, so here's how this works. Your calculator will do the derivative for you and then plug in the 8 for you as well. And here's how this works. I'm going to show you a couple different things here. So if you guys would, do this with me. I'm going to go to my y equals, and I'm going to enter v of t in there. So v of t, is 0.66 x squared plus 13.2x plus 66. Let's give you a second to get that entered in there. Once you've got that entered in there, just quit out of that screen. Just like, second quit, second mode for quit. Looks like you're all there. Okay, so I'm going to quit out of there as well. And here's where something magical will happen. Push math, which is right below alpha. Push math, and then just the number 8. Math 8. And look what shows up. Isn't that lovely? So math 8 is a numerical derivative calculator. And listen, if the calculator is active, it is totally okay to use it. If the calculator is not active, you got to use this. But
Is there going to be a, because you know how some of the programs like mine says this, is there like a formula of how to enter?
yours says end-deriv. Okay, so you can actually get the new syntax. You can go to ti.com. I'll show you. There is an alternative way, but you can get the syntax like you're seeing up there.
Okay.
It's easy. You can just download it onto that.
Okay.
Andy.
Isn't there also a way to find it like on the graph?
Uh-huh. Yep. There is. This is a little more accurate, though.
Okay.
It is. Like, if you some decimals out there, they start to vary.
Right.
So this is a little bit more accurate. All right, so here's how you do this. Remember, d over d something means do a derivative, right? Find a derivative. So we're going to tell the calculator to do d dx. So do you see the button right by the alpha button that says xt theta n? Xt theta n. Just push that. You'll get d dx. And it'll just jump right over to the thing that you're going to find the derivative of. Now remember, we put our velocity function into the y1, right? At least I put it into y1. Have you guys ever used the variables key? Well, check this out. You see the alpha, right? And you see the skinny buttons that says, I believe it's trace. So go alpha trace. And look what shows up when you push alpha trace. Now, do you remember where you put our velocity function? Into y1. So I'm just going to select y1. So you hit alpha trace. That menu should pop up. And then, so you just hit enter because I'm highlighting y1 right now. And look, it says, let's do d dx of whatever you put into y1. And then the last thing is it says at x equals something. What do you think we're going to put there? 8. So here's what your calculator is about to do. It's going to take the thing you put into y1. It's going to do the power rule a couple of times. And then plug in an 8. And spit out an answer. How did who do it so fast? Oh, it's using a series approximation for it. If you take Calc 2, you'll learn about series. It's a pretty cool little programming thing. Yeah. So you hit enter, and voila, I got 23.76. Did you guys get the same thing? So that right there, if you go back to your question, hey guys, I know we're getting towards it. We still got like 7 or 8 minutes left. What I'm about to say, if you get it, is going to prevent frustration. If you mentally check out for the next couple minutes, will only bring really bad frustration. So we just did this all in the calculator, didn't we? And so if I did this, 23.76 units would be feet per second squared. If that's what I wrote, how much credit would I get? She knows something's coming, right? She says half. So here's the issue. This, hey, listen, you could think of this as being unfair. Like, remember the 3 decimal thing? You could think of this as being unfair, but I'm telling you this now. I'm telling you the rules of the game right now. This one really has a point. The whole 3 decimal thing is kind of random, just whatever the College Board decided. You would actually get no credit for this. It is the correct answer. It's correct numerically answer. We got the units in there and everything. You want me to show you what you'd have to do to earn full credit? It's really, really simple. You might look at that and be like, well, gee, what's the deal with that? Why is that so important? No. What is so important about that? Listen, Here's what is so important. Didn't your calculator do the derivative for you and plug in the 8? You need to communicate to me what you told your calculator to do. You told your calculator to do a derivative and then plug in 8. And believe it or not, all of those instructions are encompassed by that, aren't they? V prime, do a derivative of 8, plug in 8. So if you just have a floating number out there, 23.76, I'm like, yeah, I know that that's the right answer and everything, but how did you get there? All you have to do is write V prime of 8, and I know exactly how you got there. Your calculator did all the details for you, I get it, but you're telling me how you got there. Make sense? Anna?
If you, just solved it, would you have to put,
Oh, like if you did it by hand?
Yeah.
No. If you found what V prime was, and you showed that step with the derivative, and then you maybe plugged in the 8 in the calculator, but you clearly indicated this was a derivative, and then you plugged in the 8. You should never have any floating expressions.
But if you say A, but if you solved it by hand and then you said A.
Oh, yeah, totally.
Okay.
I'm only saying this because it's for the calculator. Like if you're showing 2 or 3 steps to get to an answer, I can follow through. I'm like, oh, look, they did a derivative, and then they plugged in an 8, no problem. But if you're using the calculator, using Math 8, or later on we'll talk about Math 9, you got to show me on your paper what you did. And I know the calculator did the details, but you got to show me what you did by using symbols. Yeah. So acceleration doesn't tell me that you indicated that you did a derivative.
But wouldn't you have,
I'm not going to assume that, right? I'm not going to assume that you know that. I really hope you do, but I'm not going to assume you do. Good luck. Okay. So again, I just want to make sure that it's really clear. You might look at it and say that's unfair. It's exactly how you be judged in May. And so I want to but I also want you to understand the rationale. Like you're telling me, here's what I am doing, and here's the answer, versus here's some answer. I'm like, well, how'd you get there? I would like to see that you communicated how you got there. All right. I am happy with that. Are you happy with that? Okay. Very good. So let's see here. I believe that's it. Yep, that is it. I told you guys on Friday that I would be happy to answer any WebAssign questions. And our little lockdown drill kind of took away 10, 12 minutes of what maybe would have been that. But we still have about 4 minutes. Is there anything bugging you about something from WebAssign in the recent? Oh, yeah, go ahead, Andy. Rational function with a tangent line.
It gives you the tangent line, but it doesn't give you what point of tangent.
Is this, okay. Is this 2, 3?
It's last next.
So that's 2, 2, I think.
Right.
Yeah, 2, 2. Okay. Yeah, 2, 3 is due tonight or tomorrow or something. Yeah. Okay, so 2, 2. It's right here. I hate it when it just automatically does this stuff. Don't really want that. Okay, so do you know which number by any chance?
It's screwed down.
11, okay. Oh, okay. Find K, here let me do a little zoom. Find K so that the line is tangent to the graph of the function. So that the line is tangent to the graph of the function. Okay, so this goes back to that principle we've talked about before. At the point of tangency, the xy of the line and the xy of the curve is the same. Slope of curve, slope of line, same. And so let's see here. I see this line right here, and I can see that the slope of the line is 2. And so if that line really is going to be tangent to that function, then the slope of the line, which is 2, had better be the same as the slope of the curve, right? So the slope of the curve would be f prime equals 1/2 k x to the negative 1/2. Does that make sense?
Yeah.
Okay. So that needs to equal 2. So let's see here. That I've got my 2 unknowns right there. 1/2 kx negative 1/2 is equal to 2. But then I also know that the xy of the line and the xy of the curve have to be the same as well. So I could say that 2x plus 2, which is just the y value of the line, has to equal k root x, which is the y value of the curve. So then maybe what we could do is solve for one or the other. I'm thinking, I don't know if one's going to be easier than the other. Solve for k on the one on the right, maybe? I don't know. So it'd be 2x to the 1/2 plus 2x to the negative 1/2 is equal to k. I don't like that.
Yeah, no, I didn't like this question at all.
Well, I don't like that solving. What if we, oops, I didn't mean to do that. I just wanted to erase this. So what if I took this one right here, the f prime one? What if I solved that one? I want to know what k is. So why don't I go with this? I'll say kx to the negative 1/2 is equal to 4. Yeah, I can't. I guess I'm just going to have to solve. I'm trying to get away from solving for k here, but I guess I'll just have to. So k is equal to 4x to the 1/2. And then I can take this, plug it in here, and get a pretty straightforward equation to solve. That'll give me x, and I can plug back in to find k. Does that make sense? So, but kind of a complicated question. But if you look at the principles are simply at the point of tangency, slope of line, slope of curve, same. Also, xy for curve, xy for the line, the same. Yeah, totally. So, but if you can take those broad principles and try to apply them, that'll get you started. But the details here are a little bit messy. Definitely give you that. Cool. Okay, it's time. See you guys on tomorrow? No, Wednesday it must be, right? Yeah. All right. Hey, don't forget the business lunch is your opportunity to do the practice quiz tomorrow. That's fine. Have a great day. See you all. Which one is it, Bailey?
Thank you.
Thank you. Number 3, so that 2-3. Thank you. Have a good day, Heather. Number 3 on 2-3A.
Yeah, it's just plugging in C and pi over 3.
Okay, so number 3.
I don't know how to simplify it.
Sure. Okay, so thank you, Andy. Have a good day.
Because like the practice of the version is a lot different.
Okay, so let me make sure. Is this one really similar to yours? You have pi over 3 like me?
I have that exact one.
Okay. So then,
The first part.
okay,
Prime
so f prime is a quotient rule, right?
Yeah.
So f prime is low d high minus high d low over the square of what's below. So then f prime of pi over 3, it would be pi over 3 times cosine of pi over 3, which cosine of pi over 3 would be, no, I think it's 1/2. I think that's the issue. Yeah. So then sine of pi over 3, that's root 3 over 2. And then that would all be over pi over 3 quantity squared. I'm pretty sure it would take that. You could clean it up a little bit. Yeah, pi over 6 minus root 3 over 2 over pi squared over 9. You know, did you see me hesitate for a second there? I always have to think about it too. I'm like adjacent, hypotenuse, opposite, hypotenuse. Okay. I do the same thing. Thank you. Have a great day. You good?
For number 10, if you just,
I'm listening.
it's like x minus 2 is on the bottom. So like for that one, how would you move the x minus 4 to the top? Or would you do quotient rule?
So this is limit as x goes. Oh, this is so interesting. Oh, horizontal tangent. Sorry, I was thinking horizontal asymptote for a second. I was like, this seems way off. Sorry. Yeah, we'll get to that later. Okay, so horizontal tangent line, we've got to find f prime.
Yeah.
So f prime is equal to low
Okay, so quotient rule.
d high. I would, yeah. Low d high minus high d low over the square of what's below. And we're going to set that equal to 0. So we did one like this, sort of like this in the summer packet. Whenever you have a rational function like that that's set equal to 0, there's only one part of the function, only one part of the fraction that can make the whole thing equal to 0. Do you know which part that is? Yeah, so let me simplify it for you. Go ahead. If I just told you a over b equals 0, what's a has to be 0 and b can't. Right. Yeah, b would be if b is 0, then the whole thing is undefined. So I just want to know where the numerator is 0, right?
Okay.
So for this one, I guess my numbers are a little bit different than yours, but I would just set the numerator equal to 0. And then so you get 2x squared minus 8x minus x squared is equal to 0. So it would be x squared minus 8x equals 0. Factoring. Does that make sense?
Yeah.
Okay. So one of them is 0, and the other one is whatever number you have based on your particular question.
Okay.
And it wants to know the x and the y, so then you're going to have to take those x's and plug them back in to get the y's through it. Okay.
Okay.
All right.
Okay.
You're welcome. What's up, Eden?
I have a question about the WebAssign 1.5 to 2.3. So they're only one submission each. Is that like